engine data ecosystem built on open standards. My name is Philip. I'm a dedicated solution architect for Allianz and working with
Ben, nice to meet you. I'm from Snowflake. I'm a sales engineer and supporting Allianz on their journey for digital transformation. Hello, Ivan. It's your turn.
Good afternoon, everybody. My name is Ivan, and I'm a technical data leader working for Allianz Technology. Before we continue with our presentation, I just would like to ask here in the room, who has been working with DB2? Could you please raise your hand? All right, several. And who has been working with Oracle? All right, now, nice. And let's now imagine, how interoperability between these two huge databases works. Actually, it's not possible. So at the end of the day, there are the guys who are downloading everything in Excel and doing data analytics out of it. Today, we would like to show you an idea or a concept how you can use open table formats and put different compute engines on it. We are going to look, first of all, at the current situation in Allianz in Germany. Then we are going to show you our new ecosystem, or talk a little bit about that, and the future architecture. Before we start with the presentation, I would like to drop some words about Allianz Technology and tell you, first of all, who we are. So we are a global service provider for IT services for Allianz. And Allianz is a German insurance company, a global one, based in Germany. We have more than 150,000 employees, and we are older than 100 years. Allianz Technology, on the other side, is taking care of the whole digitalization topics for Allianz and the whole group. And we are doing all possible things, starting from, still running data centers, infrastructure, networks, cybersecurity, over workplace services, and then at the end of the day, taking care of building web portals and applications. We are trying to be, or let's say, we are the backbone of Allianz Group, and we deliver services to enable our business to support our customers all over the world. If we look a little bit at the numbers, we have more than 13,000 employees in more than 20 countries worldwide. 30% of our workforce is female, and more than 40% of the workforce is under age of 35. There is another fact which I'm very proud of, and this is that more than 60% of the people are really technical guys writing code. And now let's look what we have in Germany in our ecosystem. I mentioned DB2 and I mentioned Oracle. So currently, what we have is a huge platform based on Oracle where we gather data, and we process that data for different purposes. The major Allianz applications are customly built by us, and we are using DB2 as a data storage. So we are injecting all the DB2 data into the Oracle, and on top of that, we have more than 50 sources coming from another systems or databases like Postgre, like SAP, and again, Excel sheets. All this data is getting into processing layer, which needs to take care of the harmonization, build up all the relations in terms of data models, and so on. And after that moment, the data gets historized, which is a huge, unique capability of the ecosystem. Because what we can offer to our users and data engineers is a full history of a lot of data over the past 20 years. And this is something what none of the systems keep in that way. All this kind of data is orchestrated by a very complex logic. Because at the end of the day, everything has been built over the past 20 years, and every single decision was very important and very useful to the ecosystem by the moment the decision has been taken. And I suppose, in case most of you are technical guys, that you know what happens when you do not refactor your code. You just pile up more and more and more logic. And this is what we have here. So the majority of the logic is built in PL/SQL, is built in Java, is built in SAS, and we have a lot of other small components taking care of ETL processes or some kind of other data processing within the ecosystem. At the end of the day, out of the historization, all the data teams can use the data either to classical data analytics or do machine learning. And this historization is really precious for machine learning. Still, this is an old ecosystem. And this ecosystem needs some kind of improvements. Or I will put it differently because I would like to go into the challenges. Has certain challenges. If we do a zoom in into the ecosystem, we will see that the first and the major challenge is the whole custom logic which has been built. We are a huge company. We are an insurance company. We are regulated. That means that a lot of things which you can buy on the market does not work for us. And we need to do something to make it work. And that means build code. And on the other side, looking particularly at the way how the whole data ingestion has been driven in the past 20 years, it's very difficult to be able to find a seamless flow. And every piece of code piles up, the logic interacts with each other, and for every topic trying to get some kind of minimal degree of automation, you build another solution. And of course, right now, if you look through the perspective of maintainability, scalability, and interoperability, it's a huge pain. You have a central team. They need to take care of everything. And of course, having 20 years of history in terms of code and logic, it's very difficult to put together and find the people who would like as well to take care of such kind of activities. Then let's look to another bottleneck, which is the processing layer. We have around 50 data sources, which are quite heterogeneous. Different databases, maybe SAP data, and so on and so on. And we have a lot of DB2 data. All this data is currently picked up by the central Oracle team and brought into the ecosystem in a different way, doing some kind of delta mechanisms, copying data over files. Every single data chain is completely unique. And everything needs to harmonize. It needs to work properly. And of course, all these kind of sources are our own built systems, which means that every system has its own release cycles. And having own release cycles forces the central team who needs to take care to bring the data into the ecosystem to align with every single system independently and try somehow to put everything together, which is a huge pain. As well as the way how technically it's done, due to the fact that there are special systems, you need to take care of handshakes, you need to take care that you ensure that the data gets properly brought from A to B, and of course you need to take care of the whole quality. And at the end, the historization, very useful component. On the other side, a huge bottleneck, because how everything has been involved over the time. In the historization layer, all the data has been kept completely pure without putting anything in terms of access management, certain compliance and data privacy regulations. And this step happens at the end when somebody wants to consume the data, which leads to the situation that all that logic needs to be somehow maintained and controlled again by the same team who controls the data ingest part. And this brings a lot of challenges for the ones who consume it due to the number of rules they need to know, due to the number of rules they need to request. And at the end of the day, even if you took back, or let's say look back into 20 years of data history, you have the challenge that sometimes your perspective on what needs to be historized and how is not the same like maybe the central team wants to do it, or maybe how the regulations who are coming on a yearly basis are planned to happen. And that means, if you follow the white arrows here on the slide, all the data gets copied. And at the end of the day, even the use cases who are consuming historized data are copying the data further and turning themselves into data silos. They keep redundancies. They have sometimes the opinion that they know better how the historization shall work. They put the data aside and sometimes even try to be more creative in terms of, I need more data, I need the data the way how I want to process it. And this gets very, very dangerous for our ecosystem because the worst side effect we have is that when you have a data silo, it could turn partially into a data source so that they produce certain data which they maybe can play directly into the data system, or maybe they try to influence the historization one or another way. And this is why last year we've decided to launch a transformative program where we in Germany designed and started implementing a new data ecosystem which is called OneDia. And our motto is where the data is at home. So we would like to create a federated model which offers unique opportunities and, of course, helps as much as possible data teams to produce data products. If we look at our initial goals, we were aiming to have a scalable and performant workloads. Of course, we want to run enterprise machine learning, not only playing with that. We want to handle any data type, and we would like to share data across the companies. I think here I can spend a lot of time talking about that architecture because it's a huge build. It's a federated approach. It includes all our technical components which we have had from the past and which we have started now. And if we look into the now, currently we are using all the strong capabilities from Snowflake and AWS. I will pause here because if we zoom into that ecosystem, we can talk in every corner a lot and then go back to our challenges. The first bottleneck is what's happening in the historization. The whole access management and data privacy is a huge pain. Right now, we have several companies in Germany. We are regulated. We have data privacy requirements like GDPR. We have as well business-related rules which could be quite different between areas, even within the same company. And having everything combined into one final step before the data gets out of the system to a data team who wants to work further with that data, we have more than 3,000 rules. And this is really huge for teams who are new, who want to drive value, and who does not know what kind of permissions they need to access certain data and if they really are going to get the right data. If we look to the second bottleneck, we are struggling mainly with how we bring the data into the ecosystem. All source systems are unique. They have unique release cycles. Some of them are still running into very, let's say, conservative approach, releasing quarterly. Some other are a little bit faster than that. And data models can change. When data models start changing, the data analytics part of everything is getting the updates or the information at last. And getting changes means we need time to process every change and adjust the way how the data is brought in, the processing. And when it's done by one central team, it's really a pain. At the end of the day, we cannot give our stakeholders a satisfying SLA on data. Sometimes the data is delayed. Sometimes the data is corrupted. Sometimes the data is not there. And based on this kind of challenges, or these two major challenges, we started last year to think and analyze what could help us so that we can at least resolve these two bottlenecks. And Philip, why don't you tell us what kind of technology could help us here?
Thank you, Ivan, for introducing us into the Allianz ecosystem and the challenges we were facing. So yeah, let me introduce you how we tackled them. A major problem or root cause we identified during this project that was people were creating their own shadow copies of data and keeping this data inside their own silos, right? Means within the data warehouse, but also within different systems, okay? Which then leads obviously to scaling and of course to consistency issues, because when the data has left the data warehouse, we have no control over it anymore, okay? So we needed a mechanism to share data or encourage people to share data even across engines. So, and building an engine-agnostic data sharing mechanism. So to allow people to consume the data in place and eliminating the need to move the data out of, let's say, our ecosystem. And this is where Iceberg comes into play. Iceberg combines the features of a data lake, where you typically are free to choose the processing engine you're using to query data to process data, and combines it with features of a data warehouse, which ensure things like consistencies by providing features like transactional safety. Iceberg does it by creating a metadata layer in S3 on top of the actual data. And this helps to ensure consistency, but also to improve performance when accessing, reading, writing the data. Iceberg is widely integrated into the AWS ecosystem, and as you might have seen today in the keynotes, we are even expanding the integration and investing a lot into our Iceberg capabilities. Iceberg is also integrated in our AI/ML ecosystem, and of course, into Snowflake. With Iceberg in place and using Iceberg as, let's say, a single source within the system, we also drastically reducing the need of tons of different and myriads of ETL processes, because you just have this single Iceberg table and then multiple readers can consume the same data set without the need of moving it between different systems. Besides that, there are 4 more features which were really helpful during our journey building this open ecosystem. First of all, there's this transactional safety. Transactional safety is really a crucial feature because we are working in a multi-tenant environment where we have multiple people accessing the same data set. So we really need to make sure that when someone reads or writes this data, it is in a healthy state. The other thing is schema and partition evolution. Because in traditional data lake environments, changing or adding just a new column, dropping a new column is a challenging thing, which even might require rewriting an entire table. So Thins or Iceberg handles schema and partition evolution on the metadata layer, and you can change it while you're running and operating with the actual data. Another challenge you typically face, especially in lakes, is compaction and optimization of data, especially when you have like streaming data sources or data sources which create a lot of small chunks and files. You need to have a mechanism which under the hood compacts the files and ensures proper performance. A feature which is especially interesting for FSI might be, I'm only working with FSI customers, might be also interesting for other customers as well, is the time travel feature. With the time travel feature, you can go back to a specific point or snapshot in time and look how the data looked like at this point in time. This feature is also especially useful. I don't know how many times I've built like these delta mechanisms to just query the increment of a data set and then pass it down to my downstream systems. Iceberg provides you this feature more or less out of the box with these time travel queries. Super useful, saves a lot of time. To summarize a bit the strategic benefits of why we've chosen Iceberg and why we think or thought it's a good fit, is first of all, it's based on open standards. So you're pretty much free and you're not locking yourself too much into, let's say, a specific vendor or a specific technology. It's super cost efficient because first of all, you're using data sharing. So you're on a storage level, you're just having this one single copy of your table, which is then shared across the engine, right? And it also sits on S3, which is very cost efficient when it comes to storage. Then it's interoperable, means you're more or less free as long as your reader supports Iceberg. You can just consume the data in place, which is true for Snowflake, but also for the AWS services. And then Iceberg has a really vibrant, and this is especially important, when you're building up new things, there's a vibrant ecosystem and community really investing into Iceberg. And as AWS does. And one thing which is also relevant in my opinion and good to understand, Iceberg is more than just a single file format. Iceberg also standardizes the way how you operate and maintain the data under the hood, which helps to standardize operations and thus allows for easier automation of this operating Iceberg tables. But Ben, why don't you tell us a bit how Iceberg is supported by Snowflake?
Thank you very much, Philip, also for the overview about the general idea about Iceberg. So maybe a question to the audience. Who is already using Snowflake as a customer, as an end user? So we see already a lot of hands. That's amazing. But before we dive into how Snowflake is supporting the idea of Iceberg, I double-click quickly on the USPs of Snowflake, why Snowflake is a perfect match for Allianz to really break down the data silos and provide the scaling capabilities. So first of all, Snowflake is really a managed service, so very built and born in the cloud, easy to use, and hopefully everybody who raised their hand can confirm it to the people sitting next to each other, not raising their hands. On the other hand, is a governed data platform which ensures a secure vision, building a vision of your data. So let's dive into why Snowflake is heavily invested in Iceberg. So if you're looking back a little bit, in the past you had different options to access data which are maybe located on an S3 bucket. This can be an external table, or you can bring in the data to an internal table. But as we can see on the visualization, the challenges were always related to external tables. So from a performance point of view, but not the best performing to get insights in a reporting area. So a lot of customer moves on to internal tables in Snowflake format. But on the other hand, you start to duplicate the data, which is something you're trying to avoid using Iceberg tables. So that's the reason if you're now seeing the benefit in terms of performance, it's quite immense. If you see already, if you use an external managed data, so Snowflake Iceberg catalog, you can improve performance already by 2 times faster. That's quite impressive. But if you're looking to an Iceberg managed by Snowflake format, then there is already a performance in par. But why is that? Because in the end, we're all consuming Iceberg. So on one hand is the way how Snowflake is bringing the data into Snowflake is through storing the data in micro-partitions. And these micro-partitions are 60 MBs compressed data, big. And if you compare it maybe on the Iceberg part managed by external, these may be much bigger, so 64 or more MBs, which causing then differences in performance. But in the end, in the long run, the vision on the roadmap for Snowflake is to bring the performance. It doesn't matter if it's external or internal managed Iceberg on the same speed and feature capability as we all like from Snowflake. Let's have a quick look. What does it mean? What's on the roadmap from Snowflake? So let's group a little bit these different capabilities because there's many features coming from Snowflake supporting Iceberg. So let's start with data ingestion, because data ingestion is very important. We all like to bring the data on a fast matter into Snowflake or into the Iceberg table, so it can be done through Snowpipe streaming or the classical Snowpipe and copy commands. If you're now looking forward, if I have the data now available in my raw layer or the bronze layer, I like to transform them, I can leverage dynamic tables. And also these dynamic tables now supporting Iceberg. So you can read the data from external managed Iceberg, transform the data, run your data pipelines, and store it in an internal managed Iceberg table. So you can really build CDC pipeline with Snowflake. And the other one, which is very important, because also Ivan talked about it, is about data sharing, data collaboration. Also this capability is supported to Iceberg managed tables. So if we bring it all together, what does it mean for Allianz, for example? With having this Iceberg strategy, they can really rely on these really differentiators, what Snowflake brings on the table. So it can be really, in this scenario, really efficient compaction. Also, it was talked by Philip about it, the easy to use, and the sharing and the market-based capabilities. We have the capability to consume the data to third parties or provide the data to other customers of Snowflake. And the most important thing is about security and governance. All the advanced governance features you already may be using on your environment is all supported. If you're talking about role-level security, masking, everything was very important, especially for an FSI customer like Allianz. So now we really covered the different opportunities, how you can leverage Iceberg features with Snowflake together. And now, Ivan, my question to you is how you like to leverage these capabilities on your Allianz roadmap.
All right, guys. As soon as you saw what Iceberg can do and what kind of opportunities we have, 2 quarters ago, we decided to go into a, let's say, implementation phase where we started improving the whole architecture for data ingest, step by step, iterative and incremental. And now if we look what we have done so far is that we've put Apache Iceberg in the middle. So we are using AWS Glue to ingest different types of data. So files, connect different databases, and as well as use data streaming. All this data goes into the Apache Iceberg layer. And there we are using the AWS Glue data catalog as a solution to work with the metadata which is there. And now the biggest and most important point here is the dotted arrows which are coming out there. We don't need anymore to copy data. So we can just take a run processing engine, for example, Snowflake, and access the data directly and build the data products without the necessity to put data outside the layer. And this is for us the so-called bronze layer. So we keep all the raw data now in that layer, or are going to expand that over time because we are doing this organically. And we have the opportunity to run whatever we want. So we can access this data with Snowflake. We can access this data out of the Amazon tech stack, for example, using SageMaker or Bedrock or some other machine learning solutions which we have built as well customly over the time. So everything is available here. And we don't need to move data. We don't need to take care of the redundancies and so on and so on. And this is what we now have done in the past 2 quarters. Let's look a little bit more concrete what's happened with access management. And some of you will say it's a mathematical improvement. At the end of the day, what we have done is we broke a little bit the chain. So instead of having all the regulations and data privacy rules and access management rules and everything else, immediately before the data consumption, we move certain rules up front, like the data privacy. So GDPR, for example. And this is as well a huge advantage that everything what goes out of that layer gets immediately compliant by design. And what we have done on top of that, for example, within Snowflake, is to separate the data by company, which reduces the complexity of applying business rules cross over the whole data model. And the point is the technology offers that. So you can optimize it always, and we didn't manage to solve this over the last 20 years within the Oracle tech stack. If we look at the facts, what we have achieved so far, so currently we are running an Oracle cluster with more than 1.1 petabyte of data. We have more than 1.5 million tables, and we have more than 50 data sources. On a weekly basis, we are processing in batch more than 8 billion rows, and in a stream, more than 130 million events. And right now, we have more than 300 data products. What we have learned so far? First of all, when we change the way how we manage the access and how we implement the data privacy rules, we can reduce the complexity by factor 3 to 5, which is huge for a team which needs to operate that. The next huge improvement is that we can get almost every data source and just take care to put it into the Iceberg layer without having any other additional complexity. Or let's say it's maybe a little bit idealistically explained, so the certain complexity will stay there, but the amount of work is heavily reduced. Then we managed to decouple from all the source systems. So the source systems could as well take care of their own data ingest. So they can bring the data instead of we are picking the data from them. And this makes us independent from the release cycles and makes the team saves the team a lot of efforts in terms of aligning of release cycles, how the data is going to get updated, when to do that, and so on and so on. And I can as well think on a recent example last week, so that we found out that, for example, in the historization layer, we again had an issue with certain interpretations, which is, I think, 2 years old. And reworking that kind of stuff is not anymore that kind of trouble. Because right now, if we want to do it, we need to postpone a lot of stuff and always decide based on priorities what is more important for us. What we see as well in the current implementation is that 80% of the tasks are fully automated. And this leaves the operational teams a lot of freedom to do more value for the time they can invest in. Right now, we are as well experimenting with parallel processing. I will say it's possible to go with more than 1,000 tables. Still, we are just playing a little bit to see how the whole topic of cost as well is going to evolve. And if we have enough value for the cost we are going to invest in. And at that moment here, I would like as well to thank to all the teams who were involved in the build, because it happened very fast. It happened in the last 2 quarters. We got a lot of support from Snowflake and AWS in terms of RSAs and so on, and our own teams did as well a great job. And this is something what I would like really to underline and appreciate. If we now look one step further, we are going to continue developing our ecosystem. And the first point is what I mentioned. We would like to create another way how the data gets into the ecosystem. Instead of copying, or let's say taking care of certain replication mechanisms, to offer the possibility to every source system to bring their own data. So just say, OK, bring your own data. We are using open table format. It's very easy how to do it. If you need some support, we can as well educate you in terms of how to use, for example, AWS Glue. And this could help us to empower a lot of data teams, which are currently federated and not tightly integrated in our ecosystem, to still work with data. And what we can do more on top, you see on the picture, the AWS Glue data catalog is missing. We can put as well open data catalog. And this open data catalog could lie completely outside the bronze layer, which will enhance and improve the interoperability as well of the metadata and make it available for more consumers. And Ben, why don't you tell us what kind of technology we can use here?
Thank you, Ivan. So let's think about what we learned today, especially what Ivan told us. So what they're planning with Vondir. So in the end, if you're looking into different options you have with Iceberg, it's really to have a no-ingest serving layer. So what does it mean in the end? So no double ingest. So really having this bronze layer, as Ivan showed you, outside of Snowflake, and then start building up your lakehouse with silver and gold in Snowflake. Or maybe you have an existing data lake, and you'd like to have read and write opportunities in this data lake. So really leverage and migrate to an open table format like Iceberg. Or maybe now you're having the opportunity to build a new modern data platform and like to build a new data lake and build on the open standards. But maybe now we have our luck here in terms of Allianz. In the moment, only Snowflake is the engine who read and write the data. But in typical organizations, there are more and more different engines using the data. And just think about if you have different engines that like to read and write against the data, or having row-level security or RBAC set up, it can be very complex, especially in between. Every tool is using their own cataloging. So suddenly you have a lot of dependencies, a lot of maintenance overhead. That's the reason we have Snowflake start to think about, OK, how we can sort this out, what would be a good approach in the end to overcome these challenges. And therefore, we introduced Polaris, an open catalog provided by Snowflake, to really solve this topic. And we're not alone with this idea. AWS supported us on the journey and others, because the really vision is to have one open catalog, different engines going through this catalog, and using the same definitions of security, using the same approaches about read and write. So as you have seen on my previous slides, that we are also on private preview on merge and read, which opened the doors as well to bring the idea together, not having external managed and then internal managed Snowflake catalog, and also really have one standard to consume the data and use different engines to build their analytics on top. So as I mentioned earlier, we have really the vision to duplicate these security challenges, to have one catalog, to really reduce the overhead within the teams. That's the reason, as mentioned, we use the open catalog idea. So what's the idea about the open catalog? Quickly to summarize. So first of all, it can run anywhere. There's no lock-in. That's very important because it's open source. So you can deploy it in your own infrastructure. You can deploy it with Snowflake. But if you change your mind, you can move around. But the RBAC definition is moving with you. So you can always switch, in the end, the infrastructure. So no lock-in. The other point I'd like to call out here is the cross-engine read and write interoperability, which is very important in the end, because you will have multiple engines to read and write this data. So as mentioned earlier, so in the moment, Snowflake is having this copy and read. That means it's very fast read, which makes us very powerful for analytic workloads, but therefore you need a managed catalog by Snowflake. But with coming with merge and read, we're coming closer together, having only one layer and one catalog, and using then in the end the opportunity of the open source program from Apache to bring these boards together to REST APIs and so on. The last point I'd like to touch really is about centralized cross-engine security and access. Because everyone knows it's very important if you access data through a Snowflake engine or other engines, you like to see the same result, you like to see the same behavior, not suddenly you have different capabilities, so you're avoiding any kind of data breach or other challenges. So really define user principal and roles in Apache Polaris or Open Catalog, manage the RBAC and Iceberg tables for user and roles, and really manage your security on the storage layer, because that's very important, that you only use the engines to get the data out, to query the data you're allowed to query. I think that's really the vision of Snowflake. Hopefully, with Allianz together, we can build this kind of solution. We can ensure that one catalog is enough. You can access the data then through different engines, through AWS native features or their native capabilities and Snowflake. So what do you think, Ivan?
Let's look at the summary. So at the end of the day, what we have done is something which creates a foundation for a very healthy way how data is processed. And having a healthy bronze layer or healthy processing of raw data is a foundation for everything. Data analytics as well as machine learning. And what we have learned by adopting open table formats is, first of all, that we can optimize access management and data privacy rules. And this helps enormous for the operability of the solution. Further, the metadata table evolution leads to scalability and, of course, shortens the time to market. The teams, and of course, if changes appears, they can go much easier into the ecosystem. Then the topic of bring your own data is quite important, because now we can turn the way how data gets into the ecosystem. Instead of pulling the data could be delivered to you. We use the same open table format, which every team can utilize. And this leads to more empowerment of affiliated teams, which maybe need just to pass through the data to be able to build a data product. And at the end, of course, the most important point, by using open table formats, we can utilize different compute engines. And I think today in the keynote, we saw as well the note that the decouplement between storage and compute will continue. And this will lead definitely to a situation where every compute engine will have a unique value proposition. And if we want to get more out of the data, we need to be able to utilize different compute engines for a different purpose. And with that, I would like to say thank you. And now we are open for questions.